Hello, everyone. This is Miss Beth from the Door County Library in partnership with Crossroads at Big Creek. We are doing all about space. And tonight we have Jamie Adrian Cordova, who is a NASA ambassador, who is going to tell us all about what's up in space right now. So, Jamie, if you would like to take it away, you are more than welcome to do so.
Sure. Thank you very much. I really appreciate the invitation to be here with you all. As Ms. Beth said, my name is Jaime Cordova, or Jamie. Either one is fine. I'm a solar system ambassador on behalf of NASA and the Jet Propulsion Laboratory, and I'm also a PhD candidate at UW-Madison in studying genetics, where the main focus of my work is trying to understand what responses bacteria have to varying oxygen levels. But what I'm going to talk to you about today is a little bit about what's up. So the title of my presentation is What's Up? Space and Its Exploration. And can you let me know if you could see, are you seeing notes or are you seeing the actual presentation?
The actual presentation is right there.
Oh, okay, awesome, fantastic. Yeah, sometimes it goes either way with Zoom. You'd think after a couple of years of doing this virtually. But yeah, so we're going to talk a little bit about what's up and space and its exploration. So we're going to talk about what's up in the sky for this month, October 2021. I'll also talk to you a little bit about current NASA missions, but most importantly, the upcoming NASA missions, in particular one that's going to be launching this Saturday, which is going to be pretty cool. So what's up on the sky this month for October 13th? In fact, tonight, if it's not cloudy up in Door County, it's very cloudy here in Madison today. But if it's not cloudy, you can actually see the moon, and just above that, you'll be able to see Saturn, and just to the east of that, you'll be able to see Jupiter. Actually, right now, you'd probably be able to see Venus towards the southwest end of the sky. But you'll be able to see this if it's not clear today, and it's clear tomorrow or at some point during the rest of the month. You'll be able to see a very similar alignment of Jupiter, Saturn, and the moon throughout the next couple of days. On October 15th and October 16th, Venus and Antares, an orange star, will actually have a conjunction. So you'll be able to see that in the southwest sky, again, right around sunset. Because of where Door County is at, I actually this is actually, if I was looking from Green Bay, there's only a very short amount of time before Venus is already setting, or before Venus sets, and before that the sky actually gets dark enough to be able to see Venus and Antares. But if you look towards the southwest sky and you have a clear look of the horizon, you should be able to see this conjunction October 15th and the 16th. Then in the early morning of the end of this month, or at the last week of this month, you will be able to see Mercury. So about an hour and a half, hour and a half before sunrise, you can actually see Mercury in the eastern sky. And so sometimes Mercury is called the morning star. And it's because you usually only see it in the morning, and it's kind of weird. You usually see it, in the fall or early on in the spring as well. What's also up in the sky is two very cool stars, Vega and Deneb. You've probably heard of Polaris, which is our North Star. Now, the reason why Vega and Deneb are pretty cool is they are very bright stars that are light years away. But despite being so far away, they are burning so hot and burning so bright that we're actually able to see them, and they look almost as if they are pretty nearby. Now, because of that, because they're burning so hot and so bright and going through their energy very quickly, these stars will likely end up going supernova on an astronomical scale pretty soon. So they're going to burn out pretty soon. Now, the reason why these two are cool, or why these stars are cool, if you know, so our Earth is on a 23.5 degree tilt. And as the Earth is rotating, that tilt actually kind of wobbles a bit across thousands of years. So right now, our current North Star, or the North Pole, is currently pointing at Polaris. But in a couple of hundreds or a couple thousand years, that will actually change to where Deneb or Vega, Deneb and Vega will eventually become the North Star. That's hundreds to thousands of years from now. But there are stars that basically take different turns becoming our North Star. Currently, in the past couple of hundred years, and for the next couple of hundred years, we know Polaris as the current North Star, where the North Celestial Pole is at. And finally, for what's up in the sky this month, for October 2021, or for the moon, I should say, for this month, we just had the moon just reached first quarter last night, and we'll have a full moon today's the 13th, next Wednesday. So next Wednesday, you'll be able to see the full moon. And what's also cool is on this Saturday is actually International Observe the Moon Night. So you'll be able to see that. So there's lots of activities. You can look up International Observe the Moon Night, and I'll share the link with Miss Beth. That way that can be sent out for whoever is interested in looking at it.
Our Astronomical Society, which is attached to Crossroads at Big Creek, is doing a viewing on Saturday.
Oh, fantastic.
So, yes, so we can have
Perfect.
anybody who's listening to this, come on out on Saturday night. And there will be a big to-do at the observatory here in Sturgeon Bay.
Fantastic. And I hope you all enjoy. I'll probably be out with my telescope as well, doing a little bit of observing on Saturday. And finally, something that's not necessarily particular to this month, but is pretty interesting. I mean, I've seen it I've seen it about 10, 20 times. And every time it blows my mind is the International Space Station. So the International Space Station is currently orbiting about 200 miles, somewhere around there, above Earth. In that range. So somewhere in that range. They're high above. I always forget the exact number. But you'll be able to actually see the International Space Station, and it looks like a bright, fast-moving star. You'll be able to see it October 20th at 6:11 a.m. for about 4 minutes. Friday, October 22nd, that one will actually be really good. It's a 6-minute transit starting at 6:12 a.m. And then October 23rd at 5:26 a.m., you'll be able to see it for about 4 minutes. And you can actually, so this is in particular to Sturgeon Bay. And it kind of varies depending on where you are or where your location is. So for example, for me in Madison, it'd be maybe a couple of seconds earlier, for example. Now, the way that you can find out when the International Space Station is transiting is you can download the NASA app, and you can input your zip code, and it'll tell you there when the space station is doing a transit over you. Or you could visit spotthestation.nasa.gov, and the same thing, you put your zip code, and you can actually get either text alerts or email alerts to tell you when the station is going over. Another website that I actually really like to recommend is called Heavens Above. Now, the reason why I personally really like to recommend this website is because Heavens Above actually gives you a little bit more, or I should say, is not as stringent with listing the transits or the passes of the International Space Station. For example, the NASA website, if it's not longer than about like a minute and a half or somewhere around there, it doesn't get listed. But Heavens Above will tell you this is a minute and a half, but it will be visible. So I strongly recommend looking at both of those resources if you're interested in seeing the space station. And that picture on the right hand side is actually a picture of the space station going over my apartment a couple of months ago. So let's talk now about what's up in space. Now I'm showing a picture of the final landing of STS-135, the Space Shuttle Atlantis, which was the final space shuttle mission. That happened in July of 2011. And the reason why I'm showing this, if there are some kids who are maybe a little bit on the younger side, you probably don't know what the space shuttle is. It's been 10 years since the space shuttle was retired, so it could be ancient history to you. For all we know, but the space shuttle took flight for or close to 30 years, I should say. Yeah, close to 30 years. And after the final space shuttle landing, so again, of STS-135, a lot of people, or there's a huge misconception that NASA hasn't been doing anything. So unless you're really following what NASA is doing, then you may not realize that there is a lot going on. So for example, the International Space Station, this year, the International Space Station last year, the International Space Station celebrated 20 full years of having a crew on board. So that means if you put it into perspective, well, now it's almost going to be 21. Now for almost 21 years, there's always been at least 1 or 2 humans who haven't been on Earth, because they're they're aboard the International Space Station. And what they do on board the International Space Station is a variety of science experiments, dealing with chemistry, dealing with biology, dealing with human health. So, for example, in fact, here at UW-Madison, we have two research groups, yeah, that are currently doing experiments on board that are related to plants. And the reason why it's important for us to understand how plants grow in microgravity, for example, just one type of experiment that they do on board, is because if we eventually want to get to Mars, we can't take all that food with us. We only have a limited amount of cargo that we can actually carry with us. So if we put it, excuse me. So we actually need to be able to grow our food, whether most likely it's going to be like lettuce, or right now they're actually growing chili peppers on board. They've grown flowers, things of that sort. So it's critical that we're able to understand these types of things aboard the International Space Station, because it's acting, and it's called a microgravity laboratory. And that's just one example. Right now, we are currently in Expedition 65 with 7 astronauts on board. And in fact, I believe 3 more people will just arrive, because they're actually filming a movie aboard the International Space Station. And we're about to switch over to Expedition 66 on October 17th. But again, these astronauts they essentially become trained scientists doing experiments on other organisms, mice, bacteria, tardigrades or water bears, if you're familiar with those, and also on themselves. So trying to understand how microgravity affects human health, or for example, working out to ensure that their bones don't degrade, and how quickly does that happen when you're in microgravity. Now, on the other hand, there are a lot of other things that NASA is doing that involves, for example, this is, I'm not sure if you could see my pointer, but the plane that's awesome. Okay, so this plane that I'm showing you is an ER-2. This plane goes up to about 60,000 feet. This plane is used for high altitude atmospheric research. For example, in fact, just a couple of months ago, this plane was flying over Wisconsin, taking measurements from some of the big storms that we had over the summer. NASA also has the Curiosity rover, in addition to the Perseverance rover that just arrived to Mars last year, doing a variety of studies. For example, Curiosity is trying to understand what the rocks of Mars look like, as opposed to Perseverance, or Mars 2020, as it's also known, which is trying to find signs of life, because we believe that Mars may have once had life. And more than likely doesn't have life now, just because it's a very dead planet. And this is actually an area that's a big interest to me, and I'll talk a little bit more about that at the end. But that's just one aspect. There's also, for example, and I'm going to go over different places in the solar system where we're at. At Jupiter, we have the Juno mission, which is trying to understand the magnetic fields that are around Jupiter, and also trying to look through using different wavelengths. So, for example, X-rays, trying to look through those very thick clouds to try and understand what's going on underneath that. Probably one of the most famous ones is the Hubble Space Telescope, which has been teaching us a lot about the universe, and even planets, worlds within our own solar system. And we're going to talk about what its successor, not necessarily its replacement, but its successor in a little bit. We have New Horizons, which flew by Pluto back in 2015 and is still going on. And in fact, early last year, did a quick study of an asteroid, of a Kuiper Belt object, which is sort of like an asteroid that's way out past Pluto, and to teach us about what's beyond Pluto and what's far out there. And even farther out, which has now exited our solar system, are the Voyager missions. The Voyager missions launched in the late 1970s, early 1980s, and they have actually now exited our solar system. They are the only. There's Voyager 1 and Voyager 2. They are the only spacecraft that have been able to exit our solar system, and they're still sending information back to us. They're still functioning, trying to tell us about stuff that's out there, just mostly on the matter that's out there. They're not doing as much science as they were early on. And these are just 6 of a lot of missions. So these are all the missions that NASA that currently has active. And I should say this is in terms of probes or spacecraft. NASA still does a lot of research here on Earth in itself. And these are both those that are currently operating and those that are coming up in the future. So for example, coming up in the future is the James Webb Space Telescope, which we'll be talking about pretty soon. You also have Da Vinci and Veritas, which will be going to Venus. Now, the first time that NASA is going back to Venus in almost 40 years, roughly. So there's a lot. So we've got a lot of the solar system covered. I am most excited for Venus. Venus is my favorite planet. So I'm most excited that we're going back to Venus. And I see there's something in the chat. Just want to make sure. Does that plane break the sound barrier? Would that account for loud booms a month ago in Door County over Lake Michigan? No. So the ER2, it does go pretty fast, but I don't believe it breaks the sound barrier. Now, what you may be thinking of, I also happen to be an aviation photographer. So what you may be thinking of is about a month ago, we did have Northern Lightning out in Volk Field in, I believe, Juneau County. Or Camp Douglas. I'm not sure the exact county. But there were a lot of aircraft, military aircraft that were doing tests. And occasionally they go up, they do break the sound barrier. They do it at very high altitudes. But that's more than likely what you heard. No problem. So let's talk. So again, we've talked now about what's up in the sky, what NASA is currently doing. Let's talk a little bit about 2 missions that are coming up, particularly the Lucy mission. So the Lucy mission is going to be launching October 16th of this year. So on just a couple of days, and I actually have a mentor who's working on it, and she's very excited and also very nervous that it's finally getting off the ground. And we also have the James Webb Space Telescope, which is planned to be launching December 18th, 2021. Finally. And I'll share why I say finally in a bit. And if you're around my age or older, if you're not a kid, you understand why I'm saying finally. But anyway, first let's get to Lucy. So Lucy will be launching, like I said, October 16th from Cape Canaveral, Florida, aboard if you're a rocket fan or like myself, aboard an Atlas V rocket. And it's going to be traveling. It won't make its first measurements until 2025. So it's going to be traveling for about 4 years before it makes its first measurements. Now, where it's going is that, so here we're looking at our inner solar system. If we zoom out a little bit outside of Mars, we have the asteroid belt. And so in addition, so these asteroid belts, or this asteroid belt, which contains both asteroids and comets, these are essentially remnants of our ancient solar system. And by studying these, by being able to study these, we can actually understand not only the formation of planets, but also what our early solar system looked like. So Lucy is going to go and study some of these, which are known as Trojan asteroids. These share an orbit with Jupiter, so this is actually Jupiter, and these are Trojan asteroids that are orbiting along with it. And these Trojan asteroids are a diverse group of asteroids that, if we study them, will give us a lot of information about planet formation. Now, the cool thing about Lucy is that it's not going to study 1, 2, or 3. It's actually going to end up studying 7 Trojan asteroids. And it's going to do that across about 6 years. No, I can't do math. Across 8 years. Now, the way that this is going to happen is Lucy is going to take off. It's going to have 2 Earth gravity assists. It's going to study 1, and then it's going to study 2 of its targets. It's going to come back around to Earth, and I wish I had a diagram of its trajectory. It's going to come back around to Earth for another Earth-assisted gravity pull and Earth-assisted gravity push. Basically, what that means is you can think about it as sort of like how would I explain this? So basically what's going on is Lucy is going to take advantage of Earth's gravity. So Earth's gravity is essentially in a well, or there's an Earth gravity well. Think about it kind of like a funnel, essentially. What it's going to do is it's going to pass just outside of of Earth's gravity's influence, where it'll use that funnel, that gravity well, essentially as a slingshot. That way it can gain some speed and be able to move faster and get to its targets a lot quicker. For example, I hope that makes sense. Now, like I said, it's going to be studying 7 different Trojan asteroids of a variety of sizes. So in August 2027, it's going to study Eurybates and I always mispronounce this one, Quita. Then in September, then a month later, it's going to study Polymele. In April 2028, it's going to study Lucius. Then November 2028, it's going to study Oris. And it's going to do all of that in only 15 months. Now, I said that it's going to start doing its studies in 2025. Well, the 2025 date is actually a test. So it's not going to necessarily study a Trojan asteroid, but it's actually going to study another asteroid that's out in the asteroid belt, going to do a pass of it just to double check that everything's working out okay. And it's able to collect the science properly. Then once it studies Oris, for example, once it studies Oris at the end of those 15 months, it's going to go back around to Earth and do that third gravity assist, and then go and study Patroclus and Menoetis. I'm sorry that I'm not pronouncing that correctly. And these are pretty cool because this is a set of binary Trojan asteroids. You can see in that little GIF down at the bottom that they're actually sort of orbiting around each other, which is actually pretty interesting. We're not sure what the cause of that is. So once Lucy, at each one of these Trojan asteroids, Lucy is going to study the surface geology. It's going to look at the color and the composition of the surface. It's also going to investigate what the interior looked like. Is it solid, or is it sort of more like a pile, or like a rubble pile? And it's also going to investigate whether whether any of these Trojan asteroids have satellites or rings around it. And by satellites, I mean essentially its own mini moon, the way that Eurybates has Quita. And because of this, or because of Lucy, we'll be able to not only understand the Trojan asteroids, but we'll also get a much better understanding of our early solar system, which up till now we have sort of an understanding from studies here on Earth, from studies from moon rocks, and some studies from Martian meteorites that have landed here on Earth. But outside of that, we don't really know much about our early solar system. And it's critical for us to understand what our early solar system looked like, not only for our solar system, but for applying that to solar systems or to planetary systems that are in other galaxies, or even within our own galaxy. So yeah. Now, speaking of planetary systems and the way that we're going to so currently, we know of at least, I forget the number because it's always changing, at least 2,000 exoplanets. Now, basically what those are planets that are outside of our solar system. And that number is always changing because they're always finding new ones. The first one wasn't found until 1994, 93, so about 27 years ago. They found one, and then it's just continued to grow and grow and grow. And I'm probably way off on that 2,000 number. It's probably way more than that. But the reason why we're interested in these exoplanets is these are places that could potentially harbor life. One of the biggest questions that scientists and really anyone asks themselves is, are we alone? Now, we're not necessarily looking for life per se when we're looking for exoplanets, but we're looking for, one, trying to understand how those planetary systems form, and two, could these be places that, based on the life that we know of here on Earth, that maybe life could exist there? Now, there have been a couple of dedicated missions for that. So, for example, the Kepler telescope, which just stopped its mission about 2 years ago. Right now, there's the Transiting Exoplanetary System Satellite, so TESS. I always forget what the second S is for. That's also dedicated to exoplanets. Well, the next mission that's going to be dedicated to exoplanets, and I should say not just exoplanets, but studying our universe in general, is the James Webb Space Telescope. So the James Webb Space Telescope, oh man, is going to be launching December 18th of this year. It's going to be launching aboard an Ariane 5 rocket out of the French Guiana. Then the reason why I joked earlier is that it's finally launching is I have a book that was published in 1999, and I wish I had it with me, that says that the Next Generation Space Telescope, which was the original name of the James Webb Space Telescope, is going to launch in 2007. It is now 14 years overdue. So the James Webb Space Telescope has continually pushed back. Thankfully, we still have Hubble. That actually got a nice repair before the space shuttle was retired. But thankfully, we still have Hubble that's been doing these studies for us. But we're eventually going to have a successor for that, and thankfully, that's where James Webb Space Telescope comes in. Now, what's cool about the James Webb Space Telescope is that it actually just arrived in the French Guiana about 2 days ago. So it's getting ready for launch. We're moving closer and closer. And a really cool story about its movement or its transfer to the French Guiana is that there was a concern that pirates could hold the telescope hostage or like for ransom. And this telescope is worth billions of dollars. And so not only was it a concern of, there could be, some sort of ransom situation, but scientists were really worried. They've been waiting over 20 years for this, and for something to suddenly go wrong during transport. Thankfully, that didn't happen. Thankfully, it made it. But there was a lot of concern about that. Normally, NASA says, "Oh yeah, here you can track the satellite, or you can track this as it's going to its launch destination." They did not do that today, or they did not do that for this one because they wanted to be really careful with that. So, just a cool little tidbit about that. Now, first, before I really dive into it, I just really want to show the telescope itself. It's a beautiful telescope that's made up of a large amount of mirrors. And in fact, that it's made up of a large amount of beautiful golden mirrors that are going to tell us a lot about not only our universe, but also about even places here within our own solar system. So what are the goals of the James Webb Space Telescope? So first, it's going to search, or the first goal, it's going to search for the first galaxies that were formed after the Big Bang. If you're not familiar, if we look farther and farther into space, we're essentially looking back in time. And James Webb Space Telescope is going to be able to do that, or to a much better resolution, I should say. It's going to determine how galaxies evolved from their formation until now. It's also going to observe the formation of stars from the first stages to the formation of planetary systems like our own. And what I had mentioned earlier is it's going to measure the physical and chemical properties of planetary systems, including our own, and investigate the potential for life in those places, whether it be locations within our own solar system, such as, for example, the atmosphere, for example, Titan, or which is a moon of Saturn, or Europa, which is a moon of Jupiter. So it's going to investigate some places like that we already have a lot of investigations on. So how does JWST compare to Hubble? Well, by a lot. So Hubble has one primary mirror that's roughly, I can't remember the exact size, I should have written it down. But it's about, let's say 10 feet, roughly, just based on the person who's there. The James Webb Space Telescope primary mirror is a lot bigger than that. And because it's a lot bigger, it's going to be able to collect a lot more light and thus collect a lot of more information. So if you're not familiar with telescopes, the diameter, or I'm sorry, the diameter of your mirror, depending on that, tells you how much light you can collect and how much you're able to see. So, for example, I have a 4-inch telescope that I like to take out, and because it's easy to take out, it's small. So I'll take it out and look for it, and by 4 inches I mean the mirror itself. I also have an 8-inch telescope that's a lot bigger, and I've used that a couple of times. It's my favorite telescope, but it is heavy because of just how wide that mirror is. But because it's wider, I'm actually able to gather a lot more light and see things a lot clearer than, for example, the 4-inch telescope. Now, so what James Webb is going to be doing and how it differs a little bit from from Hubble. And like I said earlier, Hubble isn't necessarily, or I'm sorry, the James Webb Space Telescope isn't necessarily a replacement of Hubble. It's more of a successor. It's going to build off of the discoveries that Hubble has made. So Hubble, its primary focus in terms of the electromagnetic spectrum has focused on primarily the UV region, the visible region, which is what we can see, and a little bit of the infrared region of the electromagnetic spectrum. James Webb is going to focus on primarily the infrared and a little bit of the visible. Now, the reason why this is really important, or the reason why this is so fantastic that we're going to be able to do this, is that the James Webb Space Telescope, by looking at infrared, it's going to be able to look through those stellar clouds and tell us what's hidden behind those that we haven't been able to understand with Hubble. Now, just to give you a little bit of familiarity with infrared, the person on the left, you're looking at him, you're looking at them in visible light. The person on and the same person on the right is you're now looking at them through infrared. So now you're able to actually look through that bag that is hiding his hands, and look through that. And essentially, that's what we're going to do with the James Webb Space Telescope, is being able to look beyond, beyond the dust clouds and basically see what's behind them. Now, it's also important to study infrared because it allows us to search for the first galaxies, or signs of the first galaxies, or other luminous objects that formed after the Big Bang. So just to give you a little bit of a sense of the way that the solar system and the universe formed, is you had the Big Bang, you had a lot of haziness due to stellar matter in the beginning of shortly after the Big Bang. And now until the present day, you can see that it looks a lot clearer because a lot of that stellar matter has now formed, or the majority of that, I should say, of that stellar matter is formed into galaxies, planets, and such and so forth. Well, using the infrared, we're going to be able to look back in time and look back at these early stages of the universe. Now, the reason we're going to be able to do that is because as light is moving towards us from galaxies that are far out, and as the galaxies that are farther out, we're looking farther back in time. That light is what becomes redshifted. Now, the best way to sort of explain this is think about it sort of in a sound perspective. As a siren is moving farther away from you, those sound waves are getting sort of longer. And it sounds a little bit differently as when it's closer to you. So let's say, for example, and from a sound perspective, these red lines, when it's redshifted, is what you're hearing as the ambulance is moving away from you or is far away from you, where the blue lines is as it's coming closer to you. So because we're far away from these distant galaxies and they're redshifted, if we look at them through infrared cameras or infrared instruments, we're able to look farther back and understand those first galaxies. Now, also, so basically by doing that, by being able to look farther back in time and understanding those first galaxies, we're actually also able to understand how galaxies have evolved from their initial formation up until now. If we're looking at the galaxies that are around us, those will look more recent, those are more developed or closer to their final form. Let's say, for example, this galaxy right here on this first, kind of stack, that, let's say, for example, is the Milky Way galaxy. It's developed. We know what it looks like. And as you look farther and farther away to distant galaxies, you're looking farther back in time and you're seeing how the early stages of these galaxies. So by looking at different galaxies and their whatever different stages they are in their formation, that allows us to understand how they've evolved and how they formed and how they changed throughout time, which is something that we've never really been able to do before. We were able to sort of do it with ground-based telescopes, but now with the James Webb Space Telescope, it's going to open a brand new door, or a wide, huge door into being able to understand this formation. Now I mentioned the visible and their infrared, and how it's going to be able to, how we're going to be able to look beyond the stellar matter. Well, by using okay, actually, let me just show the picture first. So with Hubble, so far we've been able to see visible light. These are the pillars of creation. But these stellar clouds is essentially a star birthplace or a star nursery. So there are stars that are being formed within these dust clouds. Well, we've never been able, or we, to a certain extent, haven't really gotten a good resolution of what's going on inside of those dust clouds, or what's behind them. From our perspective in the universe, behind whatever's behind these clouds is blocked. So we have to look through those dust clouds. So by looking at by using infrared light, we're actually able to look through them and see what's going on inside of those dust clouds, or the stellar nurseries, and understand how these stars are being formed, and also how that is leading to the formation of planetary systems like our own. And finally, so I went over a lot about exoplanets, and the reason why I go a lot over exoplanets is I'm a geneticist. I'm also an astrobiologist, meaning that I'm very interested in looking for how life originated here on Earth, how life has evolved, and also the search for life in other places within our universe. Where we'll find these is exoplanets. Unfortunately, these exoplanets are very far away. The closest exoplanet to us is about 4 light years away, which means that it would take about 40,000 years, unless we're traveling at the speed of light, which we never will get to. It'll take thousands of years to get there. So we'll only be able to study these exoplanets from far away, but some of these may actually contain life. We're not sure. We have to find them first, and then using a particularly really cool method, we actually get to investigate these and see what they contain. So the way that the James Webb Space Telescope is going to do this is 2 ways. It's going to find exoplanets using direct imaging, which basically it's going to cover up a star. There's going to be a method that will cover up the star that it's looking at, and by covering up the star, we'll be able to see what planets, or if there are any planets that are orbiting it. You could think about, sort of in a sense, like if I have my flashlight on, you can't see anything. You can't see, or you can't really see that there's 2 other cameras around there. But if I block that, now you're able to see that there's 3 cameras there, right? So that's essentially the same thing that with these, it's called sort of like a stellar shade to block the sun. I'm sorry, to block the star, not just our sun. So that's one way that we'll be able to understand these. And direct imaging is used currently, but is very rarely used for finding exoplanets. The way that's primarily used for exoplanets is known as the transit method. And this method is pretty cool because the way it works is we observe a star, and we're essentially looking for an eclipse in a sense. So the way that it works is you're observing a star, and if you suddenly see a drop in its brightness, that means that more than likely that there is a planet there. Now, we don't just say, oh yeah, because there's a drop in brightness, that means that there's a planet there. There's more further investigations that need to take place. But by investigating these stars, and by looking at different stars all at once, we'll be able to really increase the number of exoplanets that we know are out there. And using this transit method, which again is, we're looking for just simply if if an exoplanet is present, we'll also be able to look at the spectrum of these exoplanets if they have an atmosphere like our own planet. Now, the way that essentially this works is you could think of the exoplanet's atmosphere sort of acting like a prism. So as the light from the star comes through that atmosphere or that prism, it will be broken apart, which now the James Webb Space Telescope and a variety of other telescopes that are currently doing this will be able to investigate this. And basically what that tells us is it tells us what's in that exoplanet, or what's in that exoplanet's atmosphere. So for example, this is an Earth-like exoplanet. We know that we have molecular oxygen here on Earth, and that's what it sees over here. We know that we have water here on Earth, and that's what it's seeing here and here. We know that we have carbon dioxide. Unfortunately, we have a lot of carbon dioxide. Hopefully not, we stop adding more. And we see that here and here. So by looking at these spectra, or these transmission spectrums from these exoplanets, we'll be able to understand what do they contain, first of all, and second of all, do these exoplanet atmospheres contain chemicals that are similar to, or I'm sorry, not similar to what or do they have what we know life requires, which are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And that's just the very basics. There's a lot of other things that life requires. But yeah, so that's what we'll be able to do with James Webb Space Telescope. Now, when I showed it to you, you could see that it's very, very big. And there isn't a rocket that's big enough, or I'm sorry, a fairing that's big enough to contain that. So what they have to do is, to get it out into space, they have to fold it up. So it's going to be folded up inside of that Ariane 5 rocket. And after it launches, it's going to release its sun shield. So this is basically this bottom part is to protect it from the heat, and also to block out a certain amount of light. Let's cover this. And then about 6 days after launch, the telescope will be fully unfolded, and it'll start doing science about 6 months after. They are calling those 6 months. Yeah, so they're calling those 6 months essentially the 6 months of terror. So whenever we launch to Mars and we are waiting for a rover to land, it's called the 7 minutes of terror, because we're waiting to see if it landed correctly and it landed okay. Well, those 6 months of terror isn't necessarily the same thing for James Webb, because we'll be connected to it the whole time. It's called the 6 months of terror because all of that needs to unfold, and it needs to unfold correctly to for it to work properly. If you're not familiar, the Hubble Space Telescope, when it was originally launched, there was a very, very, and I'm talking millimeter error with its primary mirror that was causing it to have blurry images. Well, 1994, I believe, the Space Shuttle Endeavour launched, and it took a new lens, which was essentially or a piece of glass that essentially acted like a contact lens, to correct for that. Well, we don't have the same thing for James Webb, so it has to work the first time that it's get there. So there is a lot at stake, but it should it should hopefully work out fine, and fingers crossed. And like I said, it'll be ready for science approximately 6 months after its launch. Now that's the end of my presentation. For more information, you can go onto the NASA Science website. For more on Lucy, you can go to lucy.swri.edu. And for the James Webb Space Telescope, you can go to two different locations, which is jwst.nasa.gov or webbtelescope.org. And all of these are really good resources that I strongly encourage if you're looking for more information. And I can also answer any questions that you may have. And thank you.
Okay, thank you, Jamie. That was
No problem.
fantastic. All right. Does anybody, if anybody has any questions, we can type them into the chat.
I'm going to stop sharing.
Answer them. Okay, who is the governing body that says who can launch a spacecraft?
Interesting. So it depends. There isn't necessarily a governing body. In the United States, it is technically NASA. So for example, let's say, for example, this morning, well, it's technically NASA and technically also the Federal Aviation Administration. So for example, this morning, there was a launch of Blue Origin, which is a private space company. They have to get permissions from the Federal Aviation Administration to be able to launch. I think there has only been 1 or 2 occasions where someone launched without permission. And that is very rare, and I guarantee you that it was not just a slap on the wrist. They got a very heavy fine and in a lot of trouble for doing that. But technically in the United States, it's the Federal Aviation Administration. NASA also plays a part in that. Internationally, there are respective governments, the respective governments control over that. But there is also a variety of United Nations treaties or agreements, I should say, and outside the United Nations as well, on launching and putting things up into space and putting things on other planets. Because when it comes to, let's say, for example, launching things just out into orbit, when you launch things into orbit, well, there is going to be stuff that just gets left up there and it's contributing to space junk. And it could also not only contributing to space junk, but if it's not controlled, it could eventually potentially burn up here into fall back down to Earth. I can't remember where it's at, but Sputnik 2, I know, crashed here in Wisconsin. So for example, that was a situation of sort of uncontrolled. And the other reason is if we're launching things to other worlds, for example, the moon or Mars, is we want to prevent something that's known as planetary contamination. Basically, what that means is that we don't want to launch a rover out into, excuse me, we don't want to launch a rover out to Mars that could potentially be carrying bacteria or other any type of Earth life form that could potentially contaminate that particular world. And when we get there, or for example, with Perseverance, collect samples like of that sort, and we find life, we don't want to have to question, is this Earth life or is this Mars life? So that's just one example. Good question.
Anybody else? Any other questions? We have a thank you from one of our watchers.
You're welcome. And thank you for coming.
This has been very informative. Thank you very much, Jamie, for doing this talk. You had lots of wonderful graphics. I enjoyed them very much.
Thank you.
Thank you, everyone who is watching remotely. And thank you very much for those folks who are watching this later on our recording. So, all right, ladies and gentlemen, that is everything. Have a lovely evening.
Have a good one.
Yeah.
Thank you for having me.